poking right.
Yeah, we don't want to poke them in the eye.
Hold
Okay.
like this and poke that way.
Okay, hold it down and poke down.
You're not going to have any injuries in the classroom.
So hold it. Are you okay? You got it?
I'll stop.
So hold it down like this, one of the kids, and have the other kid poke down on it. How's that? All right, that's even better yet. On the table and poke it, and you see what happens. It tears apart. Okay, which of the materials passed the scratch test the best? The scratch test first.
The scratch test.
The orange one and the black and white one.
Yeah.
Which one passed the poke test the best?
The same two.
Brown two.
Same two? Okay.
Yeah.
Greg doesn't agree?
I just.
The black one got a hole.
Did you get a hole?
Okay. Now, last thing. Take the materials, hold them up to your mouth and try blowing through them. To see if CO2 would pass through them. I think we're back, now we're just down to the orange one and the black one. Which one would not pass CO2?
Or not.
Would not.
Oh.
You can blow through the orange one.
Yeah.
Go through that.
Right,
Will
so
not pass.
you don't want that. You don't want CO2.
Will pass.
Black and white.
Will not pass CO2. You don't want CO2 coming into your
Right, and
body.
when you say will not pass CO2
Yes.
test, will not pass, does not pass the CO2 test.
Right.
Will pass.
Oh,
CO2.
I'm sorry.
That-
Does it
that's
pass the
what it
test or
does.
pass CO2? Which one does not pass CO2, period? Will not allow CO2 through.
There you
The
go.
black and white one.
Right.
Okay, so what have we got so far? For the inner layer, the purple one.
Yep.
For the outer layer, the black and white one.
Right.
Okay, only thing we have to do now is we have two more things to check for. That is, which one is the best thermal protection, which one reflects body heat in, and which one will protect us against radiation, such as UV light. Okay, Bob, you're doing your thing over here with the thermal
Yeah,
parts.
that's right, yeah. One of the things is you want to be able to get that light as close as you can to it. It may be the goosenecks that Bob has purchased. If you've got two people, you may have one person hold it, so you can actually, we want to bring that cup up so that the top of the cup is almost equal with the bottom.
And once you do that, how long do you have to leave it there?
Let's try a minute again and see what happens.
You use a shallow cut?
No, in any event, this was 30 seconds, and this lamp was working a little better. So, after 30 seconds,
We haven't seen what it looks like without it.
You can look, oh, that's right.
You need to show what it looks like without the...
okay,
Let me take this one apart.
yeah, well,
Yeah.
Okay, pass this around. This shows you what the tempedots looked like before they were subjected to the heat.
that was after.
The dots actually light up once they've been
They
heated.
turned blue, so this is the one before. Yes.
The pink colors, not
If it's still
necessarily
focused.
blue, because there were a variety, and it's just random.
Just they turn colors
With heat.
Okay, that's good.
with heat.
No.
There was a mixture of 5 different
It's
colors.
hard to see because of the lilac.
Okay?
Trouble focusing.
Yeah, you know, like.
The lilac.
Okay, Greg, let's pass yours around to the other students so they can see it.
Probably the originals are all white.
Okay.
They're actually all gold.
They're not colored.
Oh, you mean the color?
They don't have any color associated with them. The original tempedots, okay? All gold or white. All right, Okay, guys, let's get on with it.
Okay.
Bob, you still playing the game?
Now, let's try the others. So, let's see what happens. Actually, the black one is the one I want.
Yeah, we took it off. Shore by the dots.
Okay. I didn't know what that was like.
Okay, oh, look at that.
Yeah.
We need that one. I think that one's still good, isn't it?
Yes.
Where is that?
I don't know where the rubber band is, but this one.
Just grab the rubber band out.
And biological samples and testing.
Okay, how we doing?
We're trying now some of the other colors.
Oh, really?
You know what?
That's one way.
I'm gonna give you guys a suggestion, Madam and Mr. Demonstrators. Do this at home. Do this at home.
Maybe do the one, the Mylar, have it and actually do it here, but have the other ones pre-done.
Okay,
You know, that way you can still show them what it should look like
with the Mylar?
with the
Before
template
it's been
dots.
heated? Yeah.
And then you can just
Well, and then
do them under the light with the other materials, but you'll be able to just immediately pop them off and, you know, demonstrate that this is what will happen.
Okay.
It's the magic oven of the kit, you know, the test kitchen.
So the key then is the one with the aluminized.
Should be.
It did.
All right, while that's going on, what we'd like to do is the following. Each of the students have a little cup with several of the UV sensitive beads in it. I'd like for the students to line their cups up on an empty spot on the table someplace, line them up in a row about 3 inches apart. Each student put their cup up there. And then student number 1, cover the first cup with the plain Mylar material, plastic film. Student, it doesn't matter which order it is, all the cups have to have a different material on them. Student number 2, use the aluminized Mylar. Student number 3, use the neoprene coated nylon, which is the black and white. Student number 4, put the canvas, the orange material on top. And student number 5, put the rayon, the purple material, up on top. And now, Mr. and Ms. Demonstrator, if you've got a nice long extension cord for your UV lights, you can click your UV light on. Yes, sir.
You need to plug it
Well,
in.
it has to be plugged in. It helps to plug it in.
That's why you have
Let's see if it works this time. Ta-da! By the way, we have sets of goggles and UV lights over here. Please take as many sets of goggles as you need and hopefully one UV light as you go. But, make sure you plug your UV light in and check it before you take it, okay? These are getting old, who knows? Okay, demonstrator, take your UV light around. It's off.
Yeah.
This is not a good thing.
Jumping back to this, and I agreed to do 3 at home. What we have here is you have the one with the clear,
Hold it over those sides.
which is almost all blue, and then you have the one with the aluminized Mylar, where you can see that it's only, actually we could get the temperature, it looks like it's about 90, 9 degrees, whereas this other maxed out at something like 103 or 104. And it worked better, but whatever.
How did it work better, Bob?
Well, it worked better when we were in the library. I don't know why.
So what's your recommendation?
Do 3 at home so they're pre-done. Do the clear and the aluminized at the library. That cuts down on the time also.
Good. You don't want to do the black and the Mylar?
We can try the black and see what happens.
Try the black one and the Mylar. Okay, that should be enough time for that one.
How long was it?
About a minute.
About a minute.
Okay, now, each student take your material away, and the beads that are in the cups are UV sensitive. Which ones lit up? The ones that, the beads that lit up are the ones that, the materials that reflected the UV away. Okay? So if the material did not do a good job of UV protection, the beads are lit up at this point. So which materials did the best job of UV protection? The solid materials, I think you'll find. The clear Mylar did the poorest job.
Right.
Okay? The aluminized Mylar and the other 3 solid ones did a pretty good job. Did they not?
Yes.
Of blocking the UV. Okay, so now we're looking for an inner layer. Bob, tell us the results of your thermal barrier test.
The black is cooked. Probably the best example. All blue. So something in excess of 104 degrees. And again, in comparison to that, the one with the aluminized, about half of the things are. And then this was the one, this was the clear, which did not work quite as well, but again.
So Bob, I think we can suffice it to say that the black material, black on the one side, white on the other, did a very poor job of blocking the temperature.
Yes.
Blocking the heat, I should say. The aluminized Mylar did the best. So, for our spacesuit, we've determined what we want for the inner layer, the purple stuff. We've determined what we want for the outer layer, something that's tough. It's that, no, not the canvas, it's the black and white stuff, okay? That does the best job. It's the toughest, it doesn't stretch, keeps out CO2, and all that sort of thing. Now, for the inner layer, what do we want for the inner layer? We want it to block heat, keep heat in, actually reflect your body heat in. We want it to keep UV radiation away from us. Which of the materials fits the bill for that one? The aluminized Mylar. I hope everybody sees. Okay? It looks like a piece of aluminum foil. In fact, I believe that campers actually use that material as blankets when they go camping.
Space blankets or thermal blankets.
Because it keeps their body heat in. Okay?
Emergency kits in your car.
There you go. So now we have our spacesuit. At least one idea of what a Martian spacesuit might look like. If you put those 3 layers together, put the purple one first, the aluminized Mylar next, and put the black and white on the outer layer, that might be what the materials for your spacesuit would look like on Mars. Is it tough?
Yeah.
Is it flexible?
Yeah.
And it's protective in the senses that we've tested for.
Right.
Okay? So that would be our recommendation to NASA. Carol, you listening? That's our recommendation to NASA for what a spacesuit might look like.
And it's flexible.
Yeah, it's flexible. That's the name of the game.
And if I would make a suggestion here, I would do only at most the clear, the black, and the aluminized, and these two, I think maybe it would be useful to test at home so that you have the right conditions with a preheated lamp, so that the clear will turn totally blue and the Mylar will not. And that typically has been about a minute, sometimes even less, with a preheated lamp and getting the bulb fairly.
So the bottom line is if we do 3 of them at home,
2 of them at home.
maybe even 3.
All right.
Because it takes so much time. I would suggest that we keep the aluminized Mylar.
Yep.
Looks like the aluminum foil, and the black one,
Okay.
as the 2 materials we're going to test during the demonstration. The other 3 perform at home, let the dots light up. And before you do it, you can mention to the kids that the dots are either gold or white to begin with. Okay, we have 2 more quick experiments. I know it's getting late. Experiment number 4 is called recycling on Mars. We know that it's really important on Mars to recycle any water that's there. As a matter of fact, I would imagine that at least some of the water in the beginning stages of life on Mars will have to be transported all the way to Mars from Earth. But fuel cells will, in fact, oxygen, hydrogen fuel cells, in addition to generating power, will also generate some water. So we'll see how it all works out. But regardless, water needs to be conserved big time on Mars. Now, there are a couple of sources of water on Mars that really need to be seriously addressed. They're called body fluids. And it turns out that, like we have said, if you are on Mars and you're outside cutting the grass, quote unquote, or doing some kind of work outside, you're wearing your spacesuit. Can you take it off if you have to relieve yourself on Mars? No. What are you going to do? You can't take it off. It might be 80 below. It might be all CO2. Not exactly a friendly environment. So what recourse do you have? Well, one suggestion that we would have for NASA to put in this spacesuit is an astronaut diaper. So that when the astronaut is outside doing his or her thing, whatever that might be, they can relieve themselves using the astronaut diaper. To that end, everybody has a piece of paper on their table and 2 cups. One marked, I think it is D4 and W4, I believe is what it is. Potential material for the astronaut diaper is in the cup marked D4. And your body fluid is the water in the cup marked W4. So at this point, simply take the cup marked W4 and pour it into the cup marked D4 and see what happens.
Some are marked backwards.
Well, that's okay.
Yeah.
You get the idea.
Pour the water in.
You might want to put the napkin out full force because mine's overflowing.
Yes, that's the idea.
Well, but
Sorry, I didn't
open
say
the
that.
napkin. We didn't say that.
Yeah, open the paper towel all the way up. That's why it's there, because it's probably going to overflow. But Katie thought this had a good wow factor too.
8.
Everybody see what happens with an astronaut diaper? How the material is so absorbent? That, in fact, is what, that sodium polyacrylate is, in fact, from what I understand, the active ingredient, if you would, in diapers. So here we have one way to, shall we say, conserve body fluids on Mars inside that spacesuit. Beyond that, let's suppose now you're indoors and you want to try to conserve that water that's in your body fluids. As a matter of fact, let's suppose that we have some body fluid that looks like this stuff. Each of the demonstrators will have a bottle of this, and all this is some green food coloring with some garlic powder. It's not nice stuff. But if you'll take a little sample of this stuff, maybe pass it around and let the students smell it like this. You bring the smell to you, okay? Try that. Just take it and take a whiff. I'll hold the cup. You fast? You know what it's like? Okay? We call this stuff our yucky water.
Yucky water?
Yucky water. Is that yucky enough for you?
Yeah, it smells like processed meat.
More diffuse.
Yes.
Yeah, you know, like that.
Destroyed all my receptors.
All right. Here's some yucky water. Let's suppose that you're on Mars and you have some of this yucky water that you have, shall we say, collected. Well, one way to recycle the water is with a filtration system. And we happen to have made up our own filtration system. And again, on page 5 of your script, it talks about how to do this at home. Don't wait till you get to the demonstration to do this. Do this at home. And if it was done right, it will still be a little on the wet side. Pour your yucky water in there. And let's see what happens. Be careful, you don't have a lot of room to pour your yucky water in here, okay? But let it percolate out a bit. And while it's doing that, let's go to experiment number 6. Experiment number 6 is in a little plastic bag in front of you. It's got some plastic inside and some yarn, and there are also a styrofoam cup associated with it. Now, we designed this specifically, demonstrators, so that if you're running out of time, you can simply give this to the kids to take home. We're going to make a parachute. And what's a parachute got to do with Mars? Well, Carol will tell you that in some cases, NASA actually uses a parachute to land rovers on Mars, because there is an atmosphere there. There are all kinds of schemes that NASA uses, but some of them, in fact, do use parachutes. It's a cheap way to descend onto the Martian surface. So, to make your parachute, take out the plastic bag that's in there and tie, you have 4 strands of yarn in addition to the plastic bag, and there's actually instructions in that bag the kids can use if you decide they want to take it home, okay? So everything is enclosed as to what to do. But since we're here, I'll tell you what to do. What we're going to do is we're going to tie the yarn to one of the holes. Take your first strip of yarn and tie it through one of the holes, either in the cup or in the plastic bag. Either way. Doesn't have to be a big fancy thing, just a quick knot and tie it through there. And connect the other end of that piece of yarn to one of the holes in your plastic bag. And continue all the way around until you've got all 4 pieces of yarn attached to the cup. Remember, do them in order. Make sure you don't cross over the yarn pieces. Match up the holes in the cup and the holes in the bag. Open the bag up and attach the holes. Attach the yarn to the holes in both.
This is going to test their ability to handle tying knots.
We debated about this in the committee meeting, right, Vince?
Yeah.
We said, well, will little fingers be able to do this easily? And we said, well, if they can't, they can always take it home. No fancy knots needed. All you got to do is just tie it through the holes and then through the holes in the cup and the holes in the plastic bag. While you're doing that, in the interest of time, since we've used plenty of it already, Jamila, could you focus on our filter for a moment, please? In your kit, you'll have just a plain plastic cup that you can take the filter out very gently. You can take the filter out and put it down in that cup to hold it. What filter?
The before and after.
The before and after, oh. Okay. Here's the material before and after. Okay? I'm going to bring it around and let everybody take a quick smell of this. Take a quick smell of that. How's that?
Wow, it's a miracle.
Better?
Better.
Better? Better?
Chocolate sausage.
See the liquid in there? Greg? Not perfect, but certainly better. Better? Higher? It's not so bad. The other stuff is pretty bad news. Well, we're trying to simulate body fluids, right guys? So there's our simulated body fluid. By the way, I see some of the garlic is passed down to the bottom. And there's our filtered water. So obviously on Mars we'd have much more sophisticated systems than a plastic 2-liter jug with sand and carbon in it. Alright? But that is how it's possible to potentially filter materials on Mars. Now, everybody got their parachutes ready? When we did this at our committee meetings, Katie gave this one a 10.
Wow.
Katie, we couldn't even get her to continue with the meeting. She wanted to go play with her parachute. Now, one thing you might do, I think Greg's going to get a 10 too. One thing you might do is have a couple of the kids, like Greg, come to the center for a second.
Okay.
And demonstrate the parachute. Okay, and now, Mr. Gray, take your film canister, since it's handy, put it in the cup, and do it again. It works still, but of course it falls faster. The idea there is that there's more gravity, if you would, simulated by the extra mass of that little canister. With the canister in the cup, that kind of simulates Earth gravity. With the canister out of the cup, which is now falling apart, with the canister out of the cup, that simulates Mars gravity. What was that?
It's when it's pulling out a certain amount, it's alarm phase.
Okay.
Bob.
Yes,
I
ma'am.
just wonder if you could do this ahead of time, if you had the time to do it all, and then just demonstrate with and without the...
You could.
I mean, if you wanted to.
But the way we thought we'd address that is to let the kids take it home.
That seems good, yeah.
Okay. I have a couple of things to mention, and we can kind of wrap this up. On page 36 of the script, it talks about what you can do with all of these materials vis-a-vis the kids. You, the demonstrator, you have inherited the battery for what it's worth. Now, these aren't high-class, top-of-the-line batteries, but feel free to take them home with you, as opposed to having the kids fight over it, okay? Students can take home the following. From experiment number 1, why is Mars red? Nothing. From experiment number 2, which was the power for Mars, nothing. In fact, I'd like for you to return the wires back to us. There's a couple of envelopes, 8.5 by 11 manila envelopes. I'm losing it. in the kits addressed to Julia Boxler, who is our contact at the library. If you will put your completed forms, and there are forms in there for the kids to sign if you want to take pictures and so forth. And there's also a student feedback form in there. We get some interesting results via those feedback things. And feedback from you, the demonstrator. If you want to put those in those manila envelopes and send them back to me, I'd appreciate that. And we'd like those wires back. From experiment number 3, they can take their glowing beads. And there are pipe cleaners at the table. You can tell the kids each one gets a pipe cleaner, and you can put your beads through the pipe cleaner, and you've got yourself an instant bracelet. I'm not sure the guys will like that, but whatever. There are supposed to be 5 beads per cup, but maybe we didn't get enough in there. In this case, in this particular kit, we just had enough for 3 beads per cup. Okay, so they can take the beads and the pipe cleaner necklace or whatever home with them, bracelet, whatever it is. As long as they don't fling the beads all over the place, pray. They can take all the materials from the Martian Spacesuit home with them. From experiment number 4, which was, whatever it was, nothing. Number 5, the rockets, they can take their film canister with them. And number 6, they can take the Ziploc bag that had all the materials for the parachute and the parachute, depending upon whether you did it or not during your demonstration. They can take all that with them, and the styrofoam cup, of course. And lastly, there are copies of Celebrating Chemistry 2018 in the kit. They can take those home with them as well. Any questions from the demonstrators?
These cups were
Martian?
marked P, whatever.
Right.
So you just might want to say pick up the cup with the P's.
Right.
I'm sorry.
They don't have a P on them.
You said the mark with the P.
Oh, they can be any marking. Those particular cups, I'll tell you what, I screwed up. I forgot to put the instructions during GAC day that they were supposed to put cups for the beads in there. So we had no cups. So Lois was kind enough to actually count out some extra cups that we had over in Mark's lab and put the little cups in the experiment number 3 for the beads. And it turns out that sometimes you will have, Mr. or Mrs. Demonstrator, you'll have 2-ounce cups, sometimes you'll have 4-ounce cups. If they're marked with something, ignore it. It's just they're extra cups that we managed to scrounge last night. Vince?
On our snow, our acrylic polymer in just outside the box here, how do they recover the water from that? Just by compressing it and squeezing it down?
Actually, if you sprinkle some salt on it, it recovers rather nicely.
Salt?
Salt.
It's very sensitive to the electrolytic concentrations. The same way, there's a certain amount of a similar material used in something like Pearl shampoo. You have that nice thick emulsion, but as soon as it hits the salt in the hair, it collapses. And in fact, if you were to stir some salt in there, you'd find that it would turn soupy.
We could have done that. We could have said, hey, here's one way where you could recover that water on Mars by adding a little salt to it. But, you know, enough's enough.
He's trying it right now.
Oh, did you put some salt on it?
Salt on top of it.
They just stir it. Oh,
It'll get there.
take a pencil.
This is very cool.
Oh, return the pencils too, gang. One final word is on page 8 of the script. It talks about materials you need to bring with you,
That's pretty fast.
including a bucket with a bunch of things in it. Please make sure you look at what you need to bring with you on page 8 of the script.
That's good.
And I put mine in a bucket all the time and bring them that way. Okay, anything else? Thank you all, demonstrators. Have a great program.
Good job, Mom.
That's good.
Okay.
Here, this is the one.
Look at that.
Right.